Chapter 11 is nice in some ways because it's bringing some themes of chapters that we've had previously. And the big difference with this chapter is we're introducing terms. So, as I was talking about way back at the beginning of the class, if you're doing flashcards, look for the words in this chapter that are going to be helpful to you. Specifically, in this chapter, one of the nice things about it is they've got, just kind of put some .11 and 11.3 are really nice summary chapters of what the terms are and what they actually mean. And we'll be talking about those today. It covers about 4 pages of the book. Practically speaking, in addition to the words, it's helpful to see these terms being used with reference to particular studies. What we're looking at here, it's a little bit lawyerly, I guess, given the police trials that are going on, some of that. We're kind of interested in courtroom interpretations of things. And in this chapter, the internal validity threats to the study are something that you should think about when you're reading a study and thinking, do I really believe this? In some respects, it's helpful to think about these when you're also trying to read something in the popular media, because quite frequently you might not get the details about these things that are really needed to understand it from a journalist article. Heater signal to listen to that. Now, the other section that she talks about in this chapter is null effects. Sometimes when you do a study, you don't find any effects. And in some cases, that's good to know, because perhaps the link that you thought was there really is not there after all. But there are a number of reasons why you might do a study and not find significant differences. To opening up the chat here, just so that I have that open. So what we're talking about are some threats to internal validity. And one of the reasons that I like this chapter is she starts out with a couple of real life study examples. And I'm sorry? And what helps is to see these flesh and blood examples. We have 6 potential internal validity threats that we're going to talk about. These apply to one group or pre-test, post-test designs. There are some internal validity threats that apply to any experiments. And it's important, given that the chapter focuses so much on all of the things that could go wrong with a study, that we think about how an experiment can still be useful. So one thing that is often reported in the literature is a pre-test, post-test design. And the reason that these studies are kind of alluring is it really seems to make sense. It kind of goes back to the initial chapters about how informal reasoning does not help us. It presents a very believable story to us. So in this particular situation, we have a bunch of people, we give them a pre-test, we put them into a treatment, and then we measure the post-test. And we say, oh, look at the change that happened. So one of the things that the studies that are presented is, say you have a bunch of campers, young children, and they're excited to be at camp. They all come in and you kind of listen to rowdy behavior that's going on. And then the intervention that you propose is, you know what, I'm not going to make sugar as readily available. And then later on you measure the rowdy behavior. And you think, oh, well, it was really high before and now it's really low later. And perhaps there are some good internal validity reasons to not believe that. I had to kind of smile in thinking about her example there because I had helped with a school in Iowa City once called Scattergood School, which is a Quaker school, and they didn't allow any refined sugar. And yes, rowdy behavior still happens. And moreover, on top of that, there's this incredible black market in candy bars that the kids kind of have, sub rosa and all of that. But yeah, there's nothing in here about a control group that we're looking at. To give flesh and blood to a more psychology example or clinical psychology example, say we have a group of depressed women, we measure the depression, we have them go through cognitive therapy, and we measure that later and go, hey, things really went down. Graphically, this is what it might look like. So here's our values here. For purposes of simplicity, she's just giving us 2 times of measurement here, and things are going down. As we point out in the statistics review to the book and in other conversations, you probably, to give further clothing to this, you might even put the confidence intervals around those 2 means to give an idea of how much variability is going on. But the story is things are decreasing. So here's a bunch of words, and these are the ones that we're going to be spending some time on. Maturation, history, regression effects, attrition effects, testing threats, and instrumentation threats. So in terms of when you read the chapter, because we can see from this morning, some of you haven't yet gotten time to get into the chapter, when you read this, be sure and watch for these words. Sometimes these threats do not come alone to the study. Sometimes it's possible to have maturation and history, or you can have attrition and instrumentation effects going on. So it's possible that in any given study, maybe these things are going to happen in concert. Move this down here to the bottom here. And when we think about what I want to say today, as we go through these examples, maturation effects and history effects and regression effects and attrition effects, testing effects, instrumentation, these can all happen in the context of this really bad experiment. And I hope as we go through this to talk more about that. Now, out of these, just to sort of give you something to perk up your ears about, when I'm talking to people, usually it's number 3 that people have a little bit of trouble wrestling with. So, regression threats, we're going to spend a little bit of time and maybe have a little bit of chatter about that. So, maturation threats. Well, you know what they say, it's not necessarily the case with with age comes wisdom, sometimes age comes alone. Well, in the case of maturation effects, people are changing over the course of time, but not due to your study. So in the context of one study of these depressed women, especially if you're looking at long-term effects, it might be the case that the decrease in depression symptoms that you're observing is due to the fact that people are simply getting older. I reviewed some papers where they will report, these are people who like psychodynamic Freudian analysis, and they'll report on people's symptoms over the course of 5 or 10 years. Well, hopefully, you're a little bit different from when you're 20 years old to when you're 30 years old. So even though in the context of this work, you might say, oh yes, things are decreasing, it could be that all of this decreasing is just due to the fact that people are older. The other thing that, I'd spent a couple of your federal grant dollars from the Fund for the Improvement of Post-Secondary Education is the age that you are at is a time of incredible change. And as I mentioned before, about you're changing about one standard deviation from your freshman year to your senior year in your ability to think critically, your vocabulary increases, your ability to think about problems that don't have a single right answer, they're a little bit uncertain, those things dramatically increase. But the problem in going out and publishing that work, because frankly, colleges and universities love to get that kind of information because it's come to Mizzou and you're going to learn something and we're going to deliver on all these rosy promises in your course catalog. But a skeptic can look at that and say, well, they're 4 or 6 or 8 years older than they were when they entered. And if you had some control group, maybe people just get smarter as they grow older, and there's nothing about a college education that really is involved in that. And it's very hard to find people who are in some sense comparable to college educated people, but who do not go and get a college education. At the beginning, I thought, I know what I'll do. I'll identify young men and women who decide to go into the military. And maybe that will control things. Now, this was back in, heaven forbid, like 1995 or so. And, I have to admit, if I were going to go to college today as an 18-year-old, I couldn't have afforded to go. I would have had to enlist in the military and avail myself of the educational benefits there. So maybe now these days I can say, well, I can identify predominantly rural Missourian men and women, and some of whom kind of sort of make the leap to try to go and get a college education, and then identify those who enlist in the military and for that period of service do things. And testing would be a bear because frequently we're sending them abroad, and when they're going through boot camp to training, they're not going to sit down and do surveys about critical thinking and puzzles, but at least there's a population out there. So, she gives some examples here in the bottom that, in the case of children, they get better at solving addition and subtraction problems as they get older. So you can't just say, here's my math program, look at how much they jump. And some people spontaneously recover from depression. As I mentioned before, studying people who are depressed is kind of interesting to me. And one of the problems there is people will spontaneously recover without any treatment. Great. Any questions on that? Oh, I got a question in the chat. Yay. Okay. Yes, it includes physical maturity too. And that's, you put your finger on, all right, so let me just read this. Does this include physical maturity too? Like if you're testing puzzle solving ability and kids get better as they get older, can you attribute some of that to increased eye-hand coordination and not their mental ability? Definitely yes. And Dave Gurian, our department, researches math ability. There is, even for something that's not like puzzle solving, just the physical act of taking a pencil and marking on a sheet of paper or moving a mouse on a computer screen. When kids are little, like kindergartners in our Columbia school system, navigating that is very hard for some of them. So yeah, that's a great comment. Now, in the case of this particular example, she's talking about a no therapy group and a therapy group. And here we see that everybody's decreasing over the course of time. The therapy group is decreasing even more. Now I have a little story to tell about that because in my career as a statistics person, it's easier to document what we call main effects. It's easier to document where were things at time 1 and where are they at time 2. And if you're using analysis of variance, you're going to have very nice power for detecting this change due to maturation of this little design. But the act of making the conclusion that this interaction is statistically significant, that is, that this decrease for the no therapy group is different from the decrease for the therapy group. That requires a lot more people in your study to find it to be statistically significant. Okay. Now we've got history threats. Well, to try to make a story about history effects that's relevant to our life, if we were to look at how you thought about the police 2 years ago and how we think about the police now, is this necessarily due to your college education? Probably not. I mean, police behavior and accountability has changed a lot given the recent events. Perhaps also our attitudes towards gun control have changed. Well, if you were doing a study and you had a control and an experimental group, this history effect is going to affect the mean. So even though you're looking at changes over the course of time, maybe something really big happened. So in this first example, to kind of tie this back to the examples that she mentions in the PowerPoint presentation, one of the examples that she talks about is a campus residence hall intervention to get people to recycle more. And in September, when everybody comes on campus, there's a certain amount of energy being used. And then we do this go green intervention, turn off the lights when you're not using them. And then we look at how many kilowatt hours we use later. Well, if it's the case that we're kind of doing this bad experiment of only the Go Green campaign, if something happens in the middle, like a national event like Texas, or someone puts out a news article that gets a lot of media play about how important it is to save energy, it's not necessarily your Go Green campaign that resulted in this. So if you had a control group, you could tell if maybe there's something about just the month of November that makes it different from September. That's not your particular study that you're doing. So in this particular case, on the right-hand side, if you had a control group, is kind of the moral of the story, you could at least assess if the change that you're seeing is attributable to your particular intervention that you have. And again, moral of the story here is we're looking for an interaction. That is, hopefully, the no campaign group is going to score relatively the same, and the campaign group that goes down is going to be less than that. But again, if there are strong history effects, that is, if both of these lines are going down a lot, as opposed to just a little in this one, then it's the case that you're going to need slightly more people to find a statistically significant interaction, right? So maturation is kind of you getting different, and history is something happened. The assassination of JFK, George Floyd, those types of things. Is that working? Okay, so here's number 3, regression effects to internal validity. I feel pretty on today in terms of talking. Regression threats to internal validity. Well, let's see, can I come up with a story for you? At the University of Iowa, they have a gifted program. That is, they do research on gifted people. And that was very interesting to me because gifted people in terms of students are really quite different depending on exactly who that gifted person is. The minority gifted students really worked hard. They didn't mess around. And majority gifted students at the University of Iowa, at least, tended to dither around. Barbara Kerr was the person that I was working with at Iowa City, and she called it white boys disease, that suburban white males who scored high on gifted things tended to not settle on a major. They tended to not attend class. They tended to not know what they wanted to do. So, it was kind of funny to recruit people for these studies, because if you went to a music venue or avant-garde music thing, you go, oh, wait a minute, there's all these people that don't respond to our survey. Maybe we could talk to them during intermission. So let me use that, talk about a regression threat to internal validity from that experience. One of the interventions that we had was to target individuals who scored very high on a measure of academic aptitude, kind of like the ACT. They were measures. And these people, the research team was not terribly sophisticated, so it makes it a nice conversation about regression threats. They were going to target, it was in some respects a bad experimental design as well, because what they wanted to do was to target people who were very good on this academic aptitude measure, and they were going to give them additional support, a tutor, increased funding, and contact with a faculty member. And what they were surprised to see is the next year, when they tested these people, they were no longer exceptional. They were no longer at the top of the class. This is due to something called regression to the mean. Maybe some of you people are into sports. So when I was learning about regression to the mean, the instructor kept talking about the sophomore slump of baseball players, that you can identify a promising young rookie baseball player and then look at them next season and, oh my gosh, they don't do nearly as well anymore. Well, if you're selecting on people in terms of their scores and you retest them, it's probably the case that they're not going to score that high on their second testing. So our gifted students were not handicapped by all of this additional support. It's the fact that the people who we identified as gifted students, to some extent, some of them, they kind of got lucky that day. And they scored above the threshold for qualifying for being in the study. And similarly, if you're talking about baseball players, rookie baseball players, some of them are just going to have a really good season, not due to any internal merit, but just because they got a little lucky. Well, when is this going to happen? If I use a measure that's not as reliable as some other measure, there's going to be more error in the scores. That is, just on the basis of chance of using an unreliable measure, I'm going to have stronger regression to the mean effects. If I use a very precise measure, I'm going to have less of it, but it's still going to be present to some extent. So give me some chat. Is this making some sense to you? So if we're talking a little bit about our depression example, if you've got some kind of a really high regression to the mean aspect going on in depression, if you've really, really got to be hurting by the time you say, I'm going to be willing to participate in your study, regression to the mean is going to happen in both of them. So this first little chart that you see in the upper left-hand corner, both groups of scores go down. It's just that hopefully if the effect is there, the scores will go down at different rates. And now in the upper right-hand one, regression to the mean is possible because the therapy group started out more extreme than your control group. So you can't really tell from this particular situation, was this therapy group effective, even though you had a control group going on. And the bottom left, this group, that is the therapy group, started out more extreme, but at the end of the day, post-therapy, they scored below the no therapy group. So in that particular case, you might argue that therapy is effective, even though your control group was not entirely comparable to the people who got into therapy. So, how might you fix this? Well, kind of depending on which of these three little scenarios you end up with in the world, you might, for example, in the lower left-hand one, figure 11.5, you could match on depression scores for the therapy and no therapy groups. That way, you'd be sure of having two groups that pre-therapy had the same levels of depression. This is assuming everybody stays in your study, by the way, but attrition is another thing we can talk about. And again, if regression to the mean is going to happen regardless of how you solicit people, in the upper left-hand corner, you're going to have to deal with the fact that both of those groups are going to decrease somewhat. Could be maturation, could be regression to the mean. So is that working for you?
So there's not really a consistent explanation to why there's a regression to the mean, but it's just a general thing that if it's really good, it'll get worse, and if it's really bad, it'll get better.
Yeah, I mean, it could be chance that, especially if you're selecting a bunch of people. So if you're selecting baseball players who really, really score well, or football players for that matter, it doesn't really matter. Or if you're talking about really, really depressed people or gifted people, just on the basis of chance, if you're selecting the top 1%, it's probably the case that those same people are not going to be the top 1%, even if you turned around the very next day and tested them again, because of just sort of chance behavior. And the less reliable of a measure you use, that is, the more scores jump around because they're not stable over the course of time, the more likely it is that you're going to see regression to the mean effects. So, to kind of riff a bit on that, the more exclusively you select for participation in your study, the more likely you are to see regression to the mean. So, I'm kind of trying to draw on your experience in high school. People would take the PSAT and MSQ test in high school, and if you score really well on that, then you get another invite to come and take the SAT. Well, what's going on there is if you're going to be a National Merit Scholar, they assume that if you score really high on the PSAT and MSQ, that some of those people who score that high are doing so due to regression to the mean. And so they give you the SAT, and at that time that I was at Iowa, that's the home of the American College Testing Program, the SAT has a few more higher discrimination items. It's a little bit more reliable than the PSAT because the PSAT is designed for administration in a given class period in high school, and the SAT is just like the ACT. You're going to be sitting on your butt somewhere and taking it for a long time. It's a more reliable measure. That's to control for regression effects because they didn't want to give out National Merit Scholarships on the basis of a 1-hour classroom assessment. So, regression effects are, the first time you see them, the first time you hear about this, you think, gee, this is really weird. It's kind of magical that people's scores change. And it's okay for you to have this be a little bit of a challenge because, well, even the word regression comes to us from Sir Francis Galton, who was looking at the heights of children based on the heights of their parents. And he found that parents who were very tall tended to have children who were shorter than they. And similarly, parents who were very short tended to have children who were taller than they. And the very first times that he was writing this, I mean, I may have shared with you, our library has its problems. But if you want to go back and pull the original article that's the very first use of regression from the British Journal of Anthropological Science, you can get it in Ellis Library. He originally called this regression to mediocrity, that the British were somehow producing mediocre people, that people who were at the extremes, very, very short or very, very tall, were somehow magically changing to have children who were more like the rest of the population. And at the time that he finally published the article, he realized this is just a statistical artifact, that it's the case that maybe there's lots of reasons why a parent might be short. My mother, for example, was 5'2", but that's due to the fact that she lived as a young girl during the war. She had like half a cup of oatmeal to eat for the day for parts of that. And as a result, she didn't grow as much. Well, then she had me. I'm somewhat tall. And similarly, people who are tall might have children who have, disadvantage as well that cause them to be shorter, or there might be other, funny idiosyncratic reasons as to why they ended up tall. It's just kind of again, if it's that issue of if you're selecting on the basis of extremes and you retest, regression to the mean can happen. Regression to the mean has some connections to things like influential observations, but it's a separate thing. I mean, influential observation is one person or a small number that cause the shape of the regression line to change. But in regression to the mean, it's if I'm looking at people at the extremes, it's going to be the case that on retesting, they're going to change. We can come back to this. I appreciate, I think it was Grace who had jumped in with a question. Okay, so attrition effects. Sometimes people drop out of your study. So in the case of the depression example, say the reason that post-test scores look lower is because the really, really depressed people have a really tough time going through the therapy. Really, really depressed people, the ones for whom it is extremely hard to even get out of bed in the morning. It's, therapy sessions take a long, long time because they can hardly bring themselves to talk. It may be the case in your treatment group that those people just say, I'm sorry, I just can't do the study anymore. And as a result, the mean of your pretest score is just going to look higher, but because of attrition on retesting, the mean will be lower, but this is because a lot of people dropped out at time 1. In the bottom part of figure 11.6, if people in the middle drop out, that's not going to have an effect on the mean as much. It might jump around a little bit, but it's not going to be a huge issue. But if there's selective attrition going on there, then that's another threat to validity. Well, in my own life, college, Well, back in the day, hopefully, well, it is better at Mizzou than it was when I was there. Attrition was 60%. That I remember when we entered college, the president of the college came in and said, "Gentlemen and women, look to your right, look to your left. At graduation, only one of you will be here. Make sure it's you." You know, it's like, ah! Well, in the same fashion, if you're trying to figure out, do people learn something while they're in college? If you're just looking at means, maybe those people who do not like to think critically, who do not like to read, maybe those people tend to drop out of college. So the freshman senior differences are not what they would appear to be based on the means. You'd really have to have the data from the individual level. Well, you know, in terms of answering this, one way to look at attrition threats, if you have enough people to not dramatically reduce your statistical significance, is to run your analysis based only on those people for whom you have complete records. So in this upper right-hand corner, if I don't include these two data points and I calculate the mean at time 1 and the mean at time 2, I'm going to say, oh yeah, these means are about the same. If I base it on all of the data I have, I've got 5.71 versus 4.32. You know, the conclusion that it's decreasing is not warranted. Okay. Here's testing. Well, if it's the case, kind of what Grace was talking about, that we show people a test and we turn around and we have them take the test again, maybe there's something about taking that test and being familiar with what these tests, these questions look like, that causes you to be able to do better upon retesting. So in 11.7 on the left-hand side, if you have a treatment and a comparison group and they overlap entirely, yeah, scores are increasing, but it's just due to the fact that you're testing them again. So again, if you have a control group, you could at least look at the fact that, you know, maybe there's a differential effect of treatment in the presence of this kind of a testing threat. Now, sometimes you can kind of fix this by looking at a format change, like you give a test, but you know, it has slightly different questions. You know, if you give exactly the same instrument twice, sometimes people will remember from before. When I would interview college students about questions like, do you think that evolution occurs, or, you know, were humans created directly by the deity? Sometimes people would report, well, yeah, I did that interview, and you know, that got, when we talked with you in the interview, that got me to thinking, and I went out and I read some books on this. Well, you know, if you ask them the question again, is this now due to their college education or due to the fact that I gave you an interview and we had a really nice conversation and you were then motivated to go out and do some research on this sort of thing? And, you know, so if you don't have a parallel form going on, you know, and it's a testing effect could be present. And again, not to sound a bit like a broken record, but if you have a comparison group, you can at least assess whether some kind of a testing effect is present. Right. Let's see, I'm getting close toward my time here, but so instrumentation effects happen when the measuring instrument actually changes. Maybe one easiest way to think about this is when you're having people rate things. You know, earlier on in the book, we talked about observation, and maybe your raters over the course of time are changing in how they score things. So if we go back to, say, the camping example where you're not going to have people have sugar, maybe it's the case that, you know, when you're exposed to a bunch of young kids who are camping, the noise, the loudness, the carrying on of the group is really pretty disruptive to you as a rater, and you're likely to say, these people are small animals. And later on, you kind of get used to what the acceptable level of mayhem is, and you don't rate it as high. That also happens if you're watching kids in school situations and you're looking at aggression. You know, sometimes the frankness and the sort of general cluelessness that kids have in dealing with other kids results in them saying some things that are a little bit shocking to you. And after a while, you start to realize, oh yeah, this is kind of how things are. Now, ways you can do this is to be sure to recalibrate over the course of time. Identifying rater drift can sometimes be helped a little bit by introducing new raters at later times, or having meetings where you videotape and you play some examples of interactions to your raters and then have them agree on what the level is. The measuring instrument changing over the course of time is an issue. This happens a little bit more than you might want to admit in a lot of educational research, because over the course of time, things like the ACT, SAT, and high school grades change. And what held before does not necessarily hold now. You know, we have some people who were admitted to Mizzou who say, my GPA is a 4.5. Well, this is because some of the high schools have gone to a plus-minus grading system. Some of our high schools have, without reporting to anybody, gone from a 1 to 4 GPA system to a 1 to 5 GPA system, which I think is a little disingenuous. High school grading policies change over the course of time. Some high schools in Missouri are notoriously lenient in their grading, and some of them are, to my thinking, a little bit overly strict in their grading policies. So even though we might say that there's an issue going on with the relationship between high school grades and how well you do in college, we need to take into account the fact that maybe high school grades are changing. One of the reasons that Mizzou used to use core GPA was as an attempt to reduce this a bit, because sometimes students would have really high GPAs because in addition to their classes, they had a lot of other classes. Not to pick on them, I mean, I did choir when I was in high school too, but it's pretty easy to get an A in choir. But the core classes, the math, the biology, the chemistry, the English, the social studies, those things tend to be more similar from school to school than other classes. And also some students also vary in the degree to which they enroll in those classes. All right, so to sum up, we've got instrumentation, testing threats, attrition threats, the old friend regression to the mean, history threats, maturation. So know those words and know those terms, and we'll come back and, you know, I'm happy to talk about this during office hours later. I got lonely on Friday, nobody else stayed around. So to sum up, you know, kind of in the couple minutes I have, and maybe this is a nice place to launch into the next part of this. These threats can happen in concert. So sometimes there are both selection and history effects. One of my friends at Ohio State, Julian Thayer, is a black jazz musician in his spare time. Well, he's not black in his spare time, but he's a jazz musician in his spare time. And we were talking, he said, you know, we were talking about the Chauvin trial. And I asked him what he thought. He said, "Oh, I can't bear to look at this. You know, I don't even, if it comes on the news, I just switch it off. It's just too much." Well, if you were studying, say, what my opinions of the news media are over the course of the past few months and what his are, there's a selection and a history of that. That the very fact of the George Floyd death is traumatic to him as a Black man. And so that is going to systematically affect the performance of somebody. They will be perhaps even less likely to stay in your study because of this historical event. Selection, attrition effects also happen. So, I guess her example is if you have people in one group that have to travel 1 mile for the study and other people have to travel 20, you're going to have maybe more attrition in the 20-mile group due to the distance from the lab. So, it might be the case that people drop out of your study because of this selection effect. So, maybe in the first case of selection in history, they still stay in the study, but this historical event has differentially affected some of the people in your study. In the case of, say, people who will drop out of your study, maybe minorities would be more likely to drop out of your longitudinal study because they don't want to be exposed to the trauma of your experiment. Okay, does that give you enough to read on? We will put a pin in it for today.